Let's go to page 96 and number 150. So it says find four non-trivial, not one-factored interval x, y whose product is, okay, so you have 8 to the 2x minus 27 to a 2y. Okay, so you want to find a factor that when you multiply you get that. So basically you're doing the factoring. Okay, so this one first, let's go and make into the lower base. Okay, so 8 is equal to 2 to the 3, and 27 is 3 to the 3, and so this one end up with 2 to the 6x minus 3 to the 6y. So let's do that first. Okay, then after that, let's go and do the difference of square. Right? Again, whenever you can do the cube also, but do the difference of square first. So it'd be 2 to the 3x plus 3 to the 3y, and you're going to get 2 to the 3x minus 3 to the 3y. And you can do the double check very quick, right? And then from here you can do the cube, okay? So this will give you 2 to the x plus 3 to the y. And so you just square this one, so it'd be 2 to the 2x. The middle term is opposite of that, so it'd be minus 2 to the x, 3 to the y. And you square that, so it'd be plus 3 to the 2y. That's for this one here. For this one, you're going to get 2 to the 2 to the x minus 3 to the y. Again, you square that, you're going to get 2 to the 2x. The opposite of it will be plus 2x, 2 to the x, 3 to the y, and be plus 3 to the 2y. And yeah, so that's your four factors. Okay, let's go to 151. Let's go. So if x plus y equal to 4 and xy equal to 2, then you're looking for x to the 6 plus y to the 6. So you have to, obviously you have to raise this to a 6th power. So you want to do the square first and then cube it after that, right? So let's do that. So x plus y equal to 4. Again, write it out first and you square. So you're going to get x squared plus y squared plus 2xy equal to 16. And we know what this is, so we can substitute. So x squared plus y squared plus 2 times 2 equal to 16. So x squared plus y squared equal to 12. Okay, so now we have a square. Okay, now we can go in cube to get that. So again, don't mess with that. Let's just go ahead and write it one more time. And let's go and cube both sides. So you're going to get x to the 6 plus 3 times x squared to the square y squared plus 3 times x squared y squared square plus y to the 6 equal to, you cube that, you get 1728. Okay, so again, this is what we need, so let's go and gather it together. Now this one we can factor out the 3x squared y squared. And we end up with x squared plus y squared. Again, from here, factor out the 3x squared, so you end up with the x squared, y squared. Okay, so now we need to do the substitution. The x squared, y squared is the square of that, so it would be 2 squared. X squared plus y squared from here is equal to 12. And this one, if you multiply, is 1. So 2 squared is 4 times 3 is 12 times 12 is 144. minus 144. So x to the 6 plus y to the 6 is equal to 1584. Okay, let's go to number 152. You have square root of x plus 1 equal to x minus square root of x minus 1. So this is a radical equation. For radical equation, you want to isolate your square roots. So move this over and move this over. So you got 2 square root of x is equal to x minus 2. Right? Move this over, move this over. Then after that, go and square both sides. So you got 4x equal to x squared minus 4x plus 4. And move this over. So you got 0 equal to x squared minus ax plus 4. Use your quadratic formula. So negative b plus or minus square root of b squared minus 4ac over 2a. So x equal to 8 plus or minus square root of 64 minus 16 over 2. So x equal to 8 plus or minus square root of 48 over 2. So x equal to, simplify this, you get 4 square root of 3. And then simplify that a bit more, so you got 4 plus or minus 2 square root of 3. Okay, and I'm going to separate the plus from the minus. Now remember, whenever you square a radical equation, you need to check all your answers. Okay, and if you put all the answers in here and check, okay, this one is no good. So only answer that's good is this one here. Okay. So remember to check. Okay, remember to check your answers. Okay, let's go to 153. Okay, number 153, you have 1 over square root of 15 plus square root of 13 plus 1 over square root of 13 plus square root of 11 plus 1 over square root of 11 plus 3 plus 1 over 3 plus square root of 7 plus 1 over square root of 7 plus square root of 5. Okay, so again, whenever you have long problem like this, you know, you have to, there's a pattern, so look for pattern and look for the trick. Okay, so if you simplify this by using the conjugate, so you have to multiply by conjugate. Okay, so multiply by conjugate, you're going to get square root of 15 minus square root of 13 on the bottom. Okay, when you multiply by the conjugate, you're going to get 15 minus 13. And do the same thing over here, you're going to get 13 minus 11, and you're going to get square root of 13 minus square root of 11. This one you want to make into square root of 9. Okay, so you're going to get 11 minus 9, you're going to get square root of 11 minus square root of 9. And same thing, so you're going to get 9 minus 7, right? Again, multiply by conjugate. So you're going to get square root of 9 minus square root of 7. So multiply this by conjugate. Okay. And if you notice, all these are on the bottom, all the denominator, you're going to get common denominator of 2, right? 2, 2, 2, 2, 2. So all the common denominator is 2. That means you can put all this together. Okay, so you end up with square root of 15 minus square root of 13 plus square root of 13 minus square root of 11 plus square root of 11 minus square root of 9 plus square root of 9 minus square root of 7 plus square root of 7 minus square root of 5. So notice all this going to get all cancelled out. Okay, all the middle going to get all cancelled out. So you end up with square root of 15 minus square root of 5 over 2. Okay, let's go to 154. Okay, find all the possible value of the x cubed plus 1 over x cubed, giving that x squared plus 1 over x squared equal to 7, and you're looking for the cube. Okay, but we need to go ahead and start with the first power, because in order to get from here to here, we need to multiply this by first power, right? So let's start with the first power, and let's go and square that. So x plus 1 over x. Since it's not giving, so we have to figure out what is this equal to. So you square that, you're going to get x squared plus 1 over x squared, and middle term would be, multiply this would be plus 2. Okay? And if you notice that this, we know these, right? So x plus 1 over x squared equal to 7 plus 2. So x plus 1 over x squared equal to 9. And if you take the square root, you're going to get x plus 1 over x equal to 3. X plus 1 over x equal to negative 3. Now because it's cubed, so we're going to able to allow plus or minus. So you have to do both. Okay? Okay, so now we're ready to do the cube. So x plus 1 over x to the cube. Okay, this use your expansion, so you're going to get x to the cube plus 3 times x squared times 1 over x plus 3 times x 1 over x squared plus 1 over x cubed. And again, this is the tool that we need, so gather that and go and factor this two of it. You can, so one of these will cancel out, so you can go and factor out the, so factor out the 3, and so this will give you x, and this will give you 1 over x. Okay. And we forgot this side. So it's equal to 3 cubed. So this is equal to 27. Okay. So start with that. Okay. So this is that, and then you cube both sides. And so x cubed plus 1. So we don't need this, equal. So 1 over x cubed plus 3. Now this over here, from here, is equal to 3. So from here, you're going to minus 9 on both sides. So you got x cubed plus 1 over x cubed is equal to 18. Now this side, you're going to do the same thing. You're going to have 1 plus 1 over x equal to 3, negative 3. You cube both sides, and so you're going to end up with the same thing, okay? Except you're going to equal to negative 27. That's the only difference. Okay, so you're going to end up with the same thing over here. Okay, so this step is the same. So you're going to have x cubed plus 1 over x cubed plus 3 times x plus 1 over x equal to negative 27. And again, you substitute. So this is the same thing, okay, same step, except you got, instead of 27, you get minus 27. And this one, you have to substitute this one. Do not substitute this, okay, because this is this one here. And so go ahead and plus 9 on both sides. So you get x cubed plus 1 over x cubed equal to negative 18. So your answer would be plus or minus 18. Okay, let's go to 155. Number 155, you have an x squared plus p of x, px plus q equal to 0, and r and s are the roots. So if you use a root equation, you're going to have x squared minus r1 would be r, and r2 would be the s. And over here would be r times s. Okay, so from here you can see r plus s equal to negative p, and r times s equal to q. So once we do that, we can go ahead and answer all the questions. Okay. So first part, you're looking for r squared plus s squared. Okay, to do that, we just start with this one and we just go and square both sides. So r plus s equal to negative p, and then you square both sides. There you go. Square both sides, so you get r squared plus s squared plus 2rs equal to p squared. And this is equal to q. So r squared plus s squared plus 2. So rs equal to q. And then we can minus over. So r squared plus s squared equal to p squared minus 2q. Okay. And so let's do the second one. Second one, you're looking for r minus s. So you cannot remember r squared plus s squared is equal to r minus s squared plus 2rs. Okay, then you can double check, right? R squared give you that, s negative x squared give you that, and the middle term would be minus 2rs. So when you plus 2rs, you get no middle term. Okay, so from here we can start to substitute. We know this from this part, so you get p squared minus 2q equal to r minus s squared plus 2. Now rs, again, we know from here is q. Okay, so since we're looking for r minus s, so we need to move this over and take the square root. Okay, so p squared minus 2q minus 4q equal to r minus s squared. So basically minus 2q. Okay. Okay, so now you can take the square root on both sides, and I'm going to move this over. So r minus s equal to plus or minus square root of p squared minus 4q. Okay. Okay, let's go to the third one. Third one, we're looking for r squared s plus rs squared. Okay, well first this is factorable, so I'm going to move this. So this is, so r squared s plus rs squared. This is equal to rs s plus r plus s. There we go. And we already know this, right? rs from here is q, and r plus s is negative p. And so this one is fairly easy, just negative pq. Okay, let's do the fourth one. Fourth one, we're looking for r to the 4 plus s to the 4. Okay, we have the square. We have the square over here. So to get to the fourth, we need to square that. Okay, so r squared plus s squared equal to p squared minus 2q. Then go and square both sides. So you're going to get r to the 4 plus s to the 4. And the middle term, you just multiply these together, so it'll be plus 2 r squared s squared equal to, you square that, you get p to the 4 plus 4q squared minus 4pq. P squared q. Okay, so double check. So sign is negative, number 2 times 2 is 4, alphabet, okay. And this is what we need, so we need to find what this is. Okay, so r to the 4 plus s to the 4 plus 2, what's the rs? Oh, right over here. So rs is equal to q, so r squared s squared is q squared. Okay, so minus 2q squared minus 2q squared. So r to the 4 plus s to the 4 equal to p to the 4 plus 2q squared minus 4p squared q. Okay, so not too bad.